Good morning, students. Welcome to Complex Analysis live lectures. In this class, we'll discuss mappings of upper half plane. That means what are all linear fractional transformations which can map upper half plane to some particular given region. Okay, and we also see the transformation of sine z. Okay, let's do it. Fine. So as I said, we would like to find. So we want to determine all linear fractional transformations, okay, that map upper half plane, say imaginary part of z greater than 0, okay, to the unit disk mod w is less than 1 from z plane to w plane, and boundary of this upper half plane, which is imaginary part of z is equal to 0, okay, are the same as this y is equal to 0, that is same as x-axis, okay, to the boundary mod w is equal to 1 in z plane, okay. So we would like to find which transformations, okay, maps upper half plane, this image of z, to the unit disk inside mod less than 1. So if we see the picture here, if we okay, so let's change this to blue. Uh, So what we have here is this one. This is x-axis and this is y-axis. So imaginary part of y, which is z is equal to x plus y. So y greater than 0, that means this part. Okay. So y greater than 0, this we want to transform. Okay. We want to find a linear transformation which transforms this image of imaginary part of z greater than 0 to the unit disk. Okay. So like, okay, inside. That means, so here this will be mapped to this part inside, and the boundary, which is this green one, so I'll write this green color, that will be mapped to this boundary here. Okay, so we want to find such linear transformation, of course linear fractional transformation. So the idea is we will want to find we want to find a linear transformation, linear fractional transformation, in which this imaginary part will go to inside, and this x-axis, this y x-axis goes to the boundary. That means points on this circle mod z is equal to mod w is equal to 1. Okay. So the idea is we will consider the general form of this linear fractional transformation, which is a z, okay, plus b by cz plus d, where ad minus bc is non-zero, and we will take some suitable points here, okay, such that whatever we get, that will be, that means if we take some points on this x-axis, say they should map to this circle, point on this circle mod w is equal to 1. Okay, so we will consider 3 points. We consider 3 points, z is equal to 0 and 1, and the point at infinity, which lies on x-axis. Okay, right. So therefore these points should map to w such that modulus of w is equal to 1, right. Using these conditions, we will find the values what possible values can happen for A, B, C, D, and those will be the linear fractional transformation. Okay, fine. So now suppose if we take, so take Z is equal to 0, okay, for which this modulus of W, okay, and mod W is equal to 1. So for with this case, what this transformation look like? Mod W is equal to 1, this implies this 1, and when you substitute Z is equal to 0, this we simply get as mod B by D, right? This is same as modulus of B is equal to modulus of D, right? So we get that mod B is equal to modulus of D when Z is equal to 0. That means Z, if at all Z is equal to 0, should map to the mod W is equal to 1, we should have mod B is equal to mod D for any this linear fractional transformation. Okay, fine. Now take Z is equal to, so this point at infinity. Okay, so if at all this point at infinity, when we discuss this linear transformation, we have seen that this point at infinity will go to a finite value if and only if C is not equal to 0. Because if C is equal to 0, then here we will have something like A by D Z plus B by D. Okay, so that when Z tends to infinity, this W tends to infinity. Okay, then this mod W is equal to 1 only if C is not equal to 0. What is the reason? Since if C is equal to 0, then our W map, this will become A by D plus A by D times Z plus B by D. Okay, we can see that when Z tends to infinity, then this implies W also tends to infinity. Okay, when Z is equal to infinity. Okay, but here mod W is equal to 1, right? So this transformation C cannot be equal to 0. So here C is not equal to 0, and when Z is equal to infinity, what is this W? W will become, if you take Z outside, this is A plus B by Z, C plus D by Z, right? So when Z is equal to infinity, what we get? W is equal to this A by C. We'll get A by C, right? This implies mod W is equal to 1 implies mod A by C is equal to 1. So therefore, mod A should be same as mod C, and because it is 1, so they should not be equal to 0. Okay. So A and C, they are not, you can clearly see that A and C are, implies A and C are non-zero complex numbers. Okay, you can call it constants, right? So therefore this W, now we can write in better way. So therefore W can be simplified further. You take A numerator common and C in denominator. So we can write this A by C times, okay, what is remaining here is Z plus B by A, Z plus B by A, which is in numerator, then Z plus D by C, which is in denominator. Okay, fine. Now one can see that since our modulus of A by C here is 1, this value is 1, this implies A by C is definitely of the form e power I alpha, where alpha is some real number. Okay, right? Fine. So therefore this is of the form e power I alpha, and we will let Z naught is equal to minus B by A and Z1 is equal to minus D by C. So with this, what we'll get is W is equal to, okay, A by C, which is e power I alpha into Z minus Z naught upon Z minus Z1. Okay, where what we know about this Z naught and Z1? Here modulus, what can you say about mod B upon mod A? Here mod B is equal to mod D and mod A is equal to mod C. So therefore mod B upon mod A is same as mod D upon mod C. Okay, so where mod Z naught, okay, which is nothing but mod B by A, we know, which is same as mod D by C, so therefore which is same as Z1. Okay. So if at all we want to transfer, as of now we have used only this part, that if you take a points on x-axis, if at all they are mapping to the points on the circle mod w is equal to 1, then that linear transformation should look like this. Okay. Now you take any point here. If we take any point, say suppose I take some point here, okay, whose say suppose z0 is point here, whose such that is here, and which goes to this one, right? Then what condition we will get, right? So we'll see that. Before that, we will try to find what is there any relation between z0 and z1. To see that, we have used so far z is equal to 0 and z is equal to 1. Now we will use z is equal to 1. Okay, so when z is equal to 1 and modulus of w is equal to 1, we get what we will get is this mod. If you take modulus, so we get 1 here, and modulus of e power I alpha is 1. Okay, so mod z minus z0 upon mod z minus z1. Okay, so if you simplify this, mod z minus z1 is equal to mod z minus z0. Okay, this implies if you write this as z minus z1 into z minus z1 bar, okay, this is equal to z minus z0 into z minus z0 bar. Okay, now we sorry, here z is 1, right? So here z is 1, that is 1 minus z1 into 1 minus z1 bar is equal to 1 minus z0 into 1 minus z0 bar, since our z value is 1. Okay, now you can simplify this, and if you write this one, what we'll get is 1 minus z1 bar minus z1, okay, minus z1 z1 bar. Similarly here 1 minus z0 bar minus z0 minus of minus, this is plus, here also it is plus. Okay, z0 bar. Okay, now we can observe that since modulus of z0 is same as modulus of z1, okay, so therefore if you square it, you will get z0 square, which is same as mod z0 into z0 bar is same as z1 into z1 bar. So these two will get cancelled, 1 will get cancelled. So what is remaining is z1 plus z1 bar is equal to z0 plus z0 bar, right? That means real part, because this is, if you call it like x1 plus I times y1, this is x1 minus I times y1, that will get cancelled. So what we will have here is real part of z1 is same as real part of z0. Okay, so this implies what are the possibilities? Either z1 is equal to z0 or z1 is same as z0 bar. Okay, because if they are different, then we don't have this. So only possibilities, but you can easily see that if z1 is equal to z0, then w is equal to e power I alpha, because this term whatever we are having here, this will get cancelled. Okay, we get a constant, okay, which is not true, because we want to find that this will go to different, right? So this is not possible. Therefore what is true is, therefore z1 should be equal to z0 bar. Hence whatever we are w is further simplified as e power I alpha into z minus z0 by z minus z0 bar, where mod z0 is not equal to 0. Okay, sorry. Yeah. Now, so here this one, okay, yeah, now we will use that, if because z0 it is, if it is here, right, if we substitute z0 in this w, okay, so this, that means when z is equal to z0, so when z is equal to z0, then what is w? W will become 0, right? That means that is this w maps z0 to 0, right? But 0, which is an interior point of this disk, 0 is an interior point here. So here we have origin, right? So this z0 is going to this origin, right? So what we want? We want to find a linear fractional transformation such that the image of z0 is greater than 0, right? And that maps to the unit disk inside mod w is less than 1. So therefore this z naught should come in such a way that it should be in this upper half plane. Okay, because if at all it is on this one, it should map to the boundary. Okay, but the value we are getting, which is w is equal to 0, so therefore only possibility for z naught is it should come from this imaginary part of z is greater than 0, right? So that this implies this z naught, okay, should be from upper half plane imaginary part of z greater than 0. Okay, so therefore what are the conditions we got? W is equal to e power I alpha z minus z naught upon z minus z naught bar, okay, where imaginary part of z naught is greater than 0. Okay, this is, so if at all we want that upper half plane should be mapped to the interior disk and boundary should be mapped to the boundary of mod w is equal to 1, then this, if you, this is the linear fractional transformation which we require. Okay, we can also show that conversely, suppose we have a linear transformation of this kind, e power I alpha z minus z naught upon z minus z naught bar, where imaginary part of z naught is greater than 0. Then we can show that under the w, this imaginary part of z greater than 0 maps to interior and boundary will be mapped to boundary. Okay, and how we can show? Geometrically we can visualize. This implies modulus of w is equal to, this will become 1, so mod z minus z naught, okay, upon mod z minus z naught bar, right? Of course imaginary part of z naught is greater than 0, so therefore mod w is equal to mod z minus z naught upon mod z minus z naught bar, right? Now one can observe that if z such that imaginary part of z is greater than 0, okay, already imaginary part of z naught we know it is already greater than 0, right? Then z and this z naught, okay, both lie on upper half plane. Okay, and not only this, that means if you go to this picture, you can draw again one more time here. Okay, so this we have here, in this we have z, somewhere is z, okay, and somewhere is our z naught. So both will be on same upper half plane. Then where will be z naught? We know z naught is, because it is conjugate, we have a perpendicular line to this x-axis. Okay, then one can check that then the distance between mod z minus z naught, okay, and mod z minus z naught bar, if we take this, then this is strictly greater than this. Why? What is the reason? Because if we use mod z minus z naught is equal to, if you call it this z as x plus iy, then this is x naught, so you can write here x naught minus plus I times y minus y naught. Okay, similarly mod z minus z naught bar is equal to mod, this is again x minus x naught plus I times this is y, okay, and minus I naught, so you have minus, so this will become plus y naught. Okay, so what is relation? If we want to see here, it should be only relation between y minus y naught and y plus y naught. Okay, as modulus of y plus y naught by triangle inequality is greater than or equal to modulus of y minus modulus of y naught, right? But we know that this, because imaginary part of y is greater than 0, so therefore this modulus is same as y. Similarly, imaginary part of z naught, which is y naught, is also greater than 0. So what we get here is same as mod y minus y naught. Okay, so therefore mod y plus y naught is greater than mod y minus y naught. This implies what we get is mod z minus z naught is strictly less than mod z minus z bar. In this case, if z is such that z, imaginary part of z is greater than 0. This implies mod z minus z naught upon mod z minus z naught bar is less than 1. This is same as saying that mod w is less than 1. So if z lies in the upper half plane, then mod w is less than 1. That means it is mapped the inside unit disk. Okay. Similarly, one can easily check that the same logic, that if z, okay, that means imaginary part of z is less than 0, that means if z lies here, okay, then one can check that then this mod w is greater than 1. That means this value now will be bigger than that, right? Fine. Okay, now if we want to show that if at all we have a point here, right, anything here, then it should go to mod w is equal to 1. That is true because if we take any point z here, okay, then one can easily check that the distance between z minus z naught is same as z minus z naught bar. Okay, if z, okay, lies on x axis, then mod z minus z naught is same as mod z minus z naught bar. Okay, that is from this picture also you can see, or you can write z is equal to where y is 0, right? So you will get same thing. Therefore in this case mod w is equal to 1. So if we have a linear fractional transformation like this, then we have seen that imaginary part of z greater than 0 map to the interior of the unit disk, and the boundary will be mapped to this one, right? That proves that these are all linear fractional transformations which can send this upper half plane to the unit disk. Okay, just to understand an example, take how we can write in this form. So suppose take, if we take w is equal to I minus z by I plus z, then how we can write that in this form, some e power I alpha, because that scalar is not there. So you can take the help of e power I pi, we know it is minus 1. So this you can write as z minus I, because minus we have taken common here, and minus I bar, because I bar is minus I. So z minus of minus I is z plus. Okay. So clearly w is in this above format, right? So therefore which maps the upper half plane to, so therefore w maps upper half plane to this mod w is greater than 1, and imaginary part of z is equal to 0 to mod w is equal to 1. Okay, fine. Now let's see the another one, another transformation, which is again interesting. So consider the transformation. Of course, there are several examples. You can, there is no ending if we start discussing each and thing. Refer the book and you can understand on your own. So we'll see something different. W is equal to sine z. Under this transformation, let's see which type of regions will map to which, right? So if you know this W, okay, if you call it as u plus iv and write sine z as simply sine x cos hy plus I times cos x sine hy, that means what we will get is u is equal to this sine x cos hy and v is equal to this cos x sine hy. Okay, so therefore depending on what x and y, we will get whatever u and v. Okay, so for example, if quickly if we start, say suppose x is equal to 0, that means we are taking the y axis. Okay, that is y axis. Then obviously u is 0 because sine 0 is 0, and v is what we'll have is cos x is 1. So we have here sine hy. Okay, so therefore this x is equal to 0 is mapped to y axis, you can call map to w, which is equal to u plus iv, so which is simply I times v or I times sine hy. Okay, so this, that means this vertical line is mapped to y axis in z plane, mapped to v axis, okay, in this w plane, right? W plane, that is this y axis in z plane maps to v axis in w plane. Okay, If we take some non-trivial one, like lines, let me take that image. Okay, so consider this one. Okay, under this w is equal to sine z, we'll see, consider x is equal to say c1. Okay, where c1 is between 0 and pi by 2. Okay, so our this c1 is any value between 0 and 0 and pi by 2. That's considering this one. This is our line, right? So y can be anything varied and x is fixed at c1, right? Now, what happens to under this map? For that, what we know is if x is equal to c1, this u will become sine c1 cos hy. So u will become, this implies u is equal to sine c1 cos hy. Similarly, v is equal to cos c1 sine hy. Okay, because where c1 is between 0 and pi by 2, so therefore sine c1 and cos c1 are non-zero. This implies we can take c1 sin c1 here, that is same as cos hy, and v upon cos c1 is sin hy. Okay, by using the identity cos square hy minus sin square hy is equal to 1 implies what we get is u square by sin square c1 minus v square by cos square c1 is equal to 1. Okay, clearly. So this one, whatever we are getting here is the right hand side of the parabola. That means this one. So whatever this line, okay, is mapping to this line. Okay, right? Because it is a parabola, whatever we have that right hand side. Now if we take, if c1 is between minus pi by 2 to 0, okay, or if you call it c2 or no problem, that means this line, if we consider this line if we consider this line, that will be mapped to this another branch of left hand side branch of this hyperbola, right? Yes, and we already seen that this line is mapped to here, right? Okay, so whatever you have, you take if upper half, then it will be mapped to upper half here and so on, right? This is quick idea. You can find more details, right? If c1 is this, then it will be mapped to left hand side of this hyperbola, whatever we are having, right? Fine. Similarly, you can check, I just will highlight and show, I mean we'll stop. Suppose if we take w is equal to z square, okay, then we already seen this is same as x plus iy whole square, so which is x square minus y square plus I times 2xy, right? So our u is x square minus y square and v is 2xy. Okay, so with, if we take any line, how it will transform under this transformation w is equal to z square. So let me take that picture and we will go through that picture. Suppose take this w is equal to z square. Okay, now consider, suppose our x value is between 0 and 1. Okay, that means you take this line L1 for example. Okay, where x1 is fixed and y1 is varying. If we consider this line, where it will map to, you can check that it will be mapping to here. Okay, by, if you simplify this by fixing x and y varying, okay, suppose if we call it as x naught, then u is equal to x naught minus y square and v is equal to x naught y. Okay, and we can put this y here, substituting y is equal to v upon x naught, x non-zero, so no problem, and put that here. Therefore u is equal to x naught square minus v square upon 4 x naught square. Okay, this implies, okay, write this as u, okay, u into 4 times u x naught square is equal to x naught square sorry, we want value of b square, so we'll just, yeah. If you take minus come, then it is 4 minus 3 square. Okay, then this is clearly a parabola, okay, with vertex x naught square comma 0, okay. Right, and focus at origin, okay. Now go back to this picture and you see that this one, whatever we are having here, this L1 will be mapped to L1 prime because it is a parabola with minus is there, so it will be in this reverse direction, otherwise it will be like this, right. Similarly, L2 will map to here and AB will map to A prime B prime, right, and this CD will be mapped to this C prime D prime, okay. So this all some examples of some transformations under which how lines will be mapped to in W plane, how lines in Z plane will be mapped to W plane, and so on, okay. There are many things which we can go through. There will be so many other examples. Consider a transformation. For example, you can take Z power half. Okay, then you will have branches and take the principal branch, under which you again check how lines, vertical lines will be or horizontal lines will be mapped, and so on. That I hope will stop here because there won't be much end for anything, right? And whatever we have this 33 video lectures. I hope you will get some understanding about this basic complex analysis course. With this base, don't stop here. You try to take even this Churchill book and try to see solve as many exercise problems are possible, and whatever examples or results we have not discussed, in case you try to do it on your own, definitely you will understand. So with this, we will stop here, and I wish everyone uh, grand success for your exams. Okay.